to lesson 36, which is using parallel and perpendicular lines. As you can see on our graph here, we have two lines, and it looks like they're parallel, but we've got to be able to tell for sure. Now, to have parallel lines, you need to have lines that have the same slope. So we need to figure out what the slope of these two lines are. Now, to do that, we just need to pick out any 2 points on the line. So I see this point right here and this point right here. All right, so for those two, we have an ordered pair of 0, 8 and 2, 7. Now do remember, with slope, our equation is y2 minus y1 over x2 minus x1. Order doesn't matter, okay, which one goes in first. Normally we go 8 minus 7 over 0 minus 2. And our slope for this would be negative 1/2. Now, if these are parallel, the slope would have to be the same for the second one. So I'm going to pick out 2 points here. I'm going to pick out that one and that one. My 2 points for this would be 0, 1 and 2, 0. Same concept, we've got to find the slope. 1 minus 0 minus 0 over 0 minus 2. So our slope there would be negative 1/2. Since these slopes are the same, then these are parallel lines. Alright, and that's the process that you're going to go through. You have to find that the slopes are the same every single time for parallel lines. Okay, for these, we need to figure out, well, they're obviously not parallel because they cross at one point. Okay, but are they perpendicular? We have to do the exact same thing. We got to figure out what the slope is. So I'm going to start with this line. I'm going to start with this one and with this one. My ordered pair for that is 0, 0 and 1, 1. All right, slope y minus y over x minus x. Our slope is 1 over 1. For our other one, I'm going to pick out 2 points on that line too. So I'm going to pick out that one and that one. So we've got the point 0, 3 and negative 1, 4. Y minus y over x minus x. What we have here is we have 1 over negative 1. Now, they're obviously not parallel lines because the slopes are not the same, but are they perpendicular? To have perpendicular lines, the slopes have to be negative reciprocals of each other. Meaning, if we look at this one, we've got a slope of 1 over 1. We flip that upside down, so it still stays 1 over 1. But because this is positive, we're going to put a negative on it. And if these are now the same, then they are perpendicular lines. Alright, now I realize if you look at the graph, it looks like they're perpendicular. You have to go through the math to be able to prove for sure that they are. We can also do that from standard equations. This one says find the equation of the line parallel to y equals negative 2x plus 3 that crosses the point negative 4, 2. Alright, well, parallel lines have the same slope, and if we look at our equation here, our slope for that one is negative 2. We just got to be able to figure out what our y-intercept is. Well, that's where we're going to use our other point, because we know that point is on the line. So we plug in the 2 for y, negative 2 for m, negative 4 for x, and then we've got a plus b when we put it in a slope-intercept form. From here, we just got to solve for b. Alright, so we've got 2 equals 8 plus b, subtract 8, b equals negative 6. Now that we've got these two, now we can say, all right, y equals negative 2x minus 6. Our slopes are the same because the slopes right here, those numbers are the same, so they are parallel. And if we wanted to, we could plug in negative 4 and 2 into these spots. We'd have negative 2 plus negative 4 is 8. 8 minus 6 is 2. So this is the equation of the line that is parallel to our original and goes through that point. For the one down below, we need to go through the point 4, negative 1, but it's perpendicular to the line this time. All right, well for this one, our slope is 2, but our perpendicular slope, this would be like 2 over 1. Our perpendicular slope would be 1 over 2. This is positive, so this has to be negative. So this is the slope of our perpendicular line, and then we're doing the exact same thing. Y equals mx plus b. So we plug in a negative 1 for y, negative 1/2 for m, 4 for x, and we have to solve for b. When we multiply these two together, we get a negative 2 plus b equals negative 1. Add the 2 over, so b equals 1. So our equation then would be y equals negative 1/2 x plus 1. That line is now perpendicular to our original, and it goes through, once again, you could check this out, throw a 4 in here. Negative 1/2 times 4 is negative 2, plus 1 is negative 1, which is what our y had to be. Alright, our next one. Given the two equations, determine if they are perpendicular or parallel. Well, you gotta figure out what the slope is to it. Alright, so easiest way for this is to put these into slope-intercept form, meaning solve for y. So this one here, we want to move the 8x over. So we've got negative 8x plus 16. And then we want to divide everything by 16 here. So y equals negative 1/2 x plus 1. Alright? To determine if they're perpendicular or parallel, all we need is this number right there. So negative 1/2. For our other one, we're doing the same thing. We move the 6x over. So negative 6x plus 12 divide by negative 3. Y equals 2x minus 4. Now our slope for this one is a positive 2. They're obviously not parallel because the slopes are not the same, but are they perpendicular? If we were to flip this one, this would become 2 over 1, and then we flip the sign, so it would be a positive 2. That would match that one. So these are parallel lines. Alright, for our next one, find the equation of the line perpendicular to the graph of y equals negative 4 that passes through the point negative 5, negative 2. Now this one you're going to have to think through a little bit. If we look at this, if we were to graph y equals negative 4, we'd come down here and we'd draw a straight across line there. And then we want it to go through the point negative 5, negative 2. So we want it to go through that point. Well, if this line is perfectly horizontal, that would mean that this point has to be perfectly vertical. What's the equation of that line? Well, that is when x equals negative 5. When you have points like, or when you have lines like this that are either parallel or not parallel, whether they're vertical or horizontal, you're going to have to think through that in that concept there. Alright? And the nice thing about this was, well, we know our original was vertical, so our new line has to be horizontal. Horizontal is always dealing with the x. Well, there it is. There's our negative 5 for the x. Alright? And I have no idea if this is the homework or not. Make sure you check Schoology. But that is basically what you are doing with this lesson. Any questions? I will be back on Monday to answer them.